All right, so kind of like how we started, we were talking about where did imaginary numbers come from. It was because when we were solving using that square root property and we had a square root of a negative number, that whoever invented quadratics and the no solutions also invented these imaginary numbers. I'm assuming, I can't remember, taking a history of math class was a long time ago. But looking at this equation, how would I solve for x? What would we do? All right? Add 8. Very good. Opposite of what we see. And what we do to one side, we do to the other. So x squared equals, what is that going to give us? Negative 36 plus 8. Negative 28. To get rid of that squared on the x, what do? Square root. And when I square root one thing, I have to square root the other side as well. All right, square rooting something squared leaves me with the x. Don't forget a positive negative because it was x squared and we don't know the value of that x. And we just learned this whole unit was about square roots of negatives, or I squareds. So a negative under a square root is a what again? I. And then we want to think about square root of 28. 7 and 4. Which one of those is the perfect square number? 4. Square root of 4 is 2. All right, so now we have a positive negative 2i. What happens with that 7? Stays inside because it's a prime number. It doesn't break down, correct? And we have our answer. We just went full circle. We started with solving to explain why or where these negatives come from, or the i's in this case, okay? And then we broke down radicals, which are square roots. Don't forget to put a plus minus. I want to look at one more, because sometimes I feel like fractions throw us off, and sometimes a different notation might throw us off. If I were to have a f of x, and let's say we have a 9x squared plus 1. F of x, when we were graphing, remember that f of x was just a fancy way of writing y. Well, when we're solving, yep, we want it to be a 0. So if it does say to solve or find the zeros, f of x is just a fancy way of writing 0. Okay? And then we solve like we've been doing. What would we do first? Very good. Subtract 1. What I do to one side, I do to the other. 9x squared equals a negative 1. Next step. Divide by 9. What I do to one side, I do to the other. So then we end up with x squared equals negative 1/9. How do I get rid of that squared? Square root. When I square root something squared, it just takes away the squared and the square root. I end up with a positive negative because we don't know the value of that x. We also know that this negative under a square root is really I. And now we have to think about square root of 1 over square root of 9 because it is a fraction. We have a top number and a bottom number, but those are perfect square numbers, aren't they? So don't think you don't know how to do this just because it's a fraction. What is the square root of 1? 1. What is the square root of 9? 3. So I really have a positive negative. 1, you said square root of 9 is 3, and then the I goes behind it. Because it sounds kind of goofy if we were to say positive negative I 1/3. Sounds better to say positive negative 1/3 I. Okay? Still, same stuff. The only thing we've really learned is the square root of a negative is really the I. And I squared is -1. Combining like terms if we're adding or subtracting. Okay? Questions? Pretty easy section. All right? We do have an assignment. I know. Ooh, over the weekend even. All right, what do you think an M3 really means? Anyone? Every third one, multiples of 3. When we talk about multiples of 3. Yes, and you know what? Hold on, let's start on 3. I'm sorry, my mistake. My mistake. One problem extra. Multiples of 3. So you're starting with, what did we say now? 3 this time. And then go to 6. And then go to 9. And then 12. And you end up with 66 because it is a multiple of 3. No, 12. What was the next one? 15. 18. 21. So